Okay, so welcome along to the seventh session here then. So this is going to be talking about our compound measures. So in terms of compound measures, there's a few things that we need to be aware of and there's a few things we need to look into. First and foremost, we're going to have a look at what are called metric measures or metric conversion. So this is a very important skill. It's very applicable for level 1 and 2. It's also going to really embed the use of this kind of multiplying and dividing by tens, hundreds, and thousands. If we're confident with this, it's going to really help us build our confidence for these bigger area questions as well. So this is a really important topic to kind of be quite nice and happy with, essentially. We're then going to move on, and all of the following topics are only for level 2 learners. Okay, so we're going to talk about what a compound measure is, and we're going to look at the most common of these, which is our speed, distance, time problems. So on the exam paper, this is not a core topic, so it might pop up, it might not. It's not guaranteed like our percentages, fractions, ratio. It might not pop up, okay? But if it does, we need to be able to recall a formula for speed, distance, and time, which I'll show you a little bit later. I'm going to talk about some of the problems with the units of time, but really we're just going to do a lot of examples on these types of questions. Now, finally, what we have is our mass density volume problems. Now, the reason I've wanted to re-record this session is because I've done a bit of research recently and I've kind of stumbled on the idea that you are always given the formula for this. Okay, there was maybe one question previously where you were given a slightly different formula and you had to manipulate it. That's no longer applicable. So that's why I want to re-record this, and we're going to just look at two questions regarding this when you're given the formula as well. So I'll explain a little bit about what these more sciencey words mean, but then hopefully what you can then do is by looking at the examples, you'll see why this topic does confuse people a little bit, but also why it's not as bad as we might think. Okay, so what is the metric system? So the metric system is absolutely awesome. It was introduced by the French during the Revolution. And essentially what the idea of it is to replace these imperial measurements, which have become really difficult to work with. So I'm sure if I were to ask anyone, how many inches are in a foot, some people might know, some people might say, oh, well, there's 12 inches in a foot. Okay. How many feet are in a yard? You might know there are 3 feet in a yard, but then it's how many yards are there in a mile? And in an imperial mile, I have no idea. This is the same with, weight when you have 16 pounds, I think it is in a stone, and how many stones in an imperial ton. All of the numbers were getting a bit different. You had this many of, maybe you had 8 of these to make one of these, and you had 24 of these to make one of these. It just gets really, really confusing. So what the French have done is come along and absolutely brilliantly realized, well, we use a base 10 number system all the time. So why not introduce the exact same with our units? So what we have essentially is we have a core unit. For length, it is the meter, Greek for measure. For weight, it is the gram, and for capacity, it is the liter. Now, all we do is we work on these. It's the idea of we count up to, once we get up to, let's say, 9 liters, once we hit the 10th liter, it gets a new, what's called prefix, a new word in front of it. Just as when we count up, we have our units, and then we get 110. Once we get 10 tens, we have 100. So it works in the same kind of premise, and it makes it a lot easier to keep track of the size of things and to convert between them very, very easily. So all metric measurements have the same prefixes. So this is what I was saying. This is the little subword in front of the core word. And it makes it a lot easier for us to kind of convert between these. Now, the whole idea of how this works is you have your base unit, and then for each multiplication or division, you get a different word in front of it. So some of these you will potentially be aware of. So, we're going to look at centimeters in a moment, but just we'll use it as an idea here. So if I were to say meters here, you've probably heard of a kilometer or a kilometer. You've probably heard of a centimeter or a millimeter. And to work out what the link is between them, you just count how many spaces it's moved. So from the meter, if I had 10 of them, I'd have a decameter. You could count in them if you want to. You could say, the car is 7 decameters away. That would mean it is 70 meters away. but we don't tend to use this metric. The same here with hecto, this would be 100 times, so this would be 100 meters. So it could be 3 hectometers away. It'd be 300 meters away. But again, we don't really use this. We use the hundreds word, and then once we get to 1,000, that's where we switch to kilo. So the ones that you've probably seen is kilo, centi, and milli. And this is the same with all. So if we have meters, if you think about grams as well, you've probably heard of a milligram, a gram, and a kilogram. You probably don't talk about centigrams, decagrams, decigrams, or hectograms, but they are all still the same thing. The same with liters as well. We tend to just use the milliliter. You might see centiliter in some places, or kiloliter. I mean, kiloliter in itself is quite a rare one. It tends to be milliliter or liter. So it can be a little bit different depending on the unit of measure, depending on what kind of industry you're in as well. You know, for chemists out there, you might see deciliter a little bit more. It's more common with concentrations, but this is the core idea here of our metric system. Each measure is just a multiple of 10, be it 10 times bigger, 10 times smaller. So if we look at some of these conversions, and so just as an idea, if I had, let's say, a millimeter and I wanted to convert this into a centimeter, all I would have to do is multiply by 10 or divide by 10, depending on which way we're going here. Very useful skill, as we'll see a little bit later on, is just to think which one's bigger. Okay, centimeters are bigger measurements, so there will be less of them in a distance. So to go from a millimeter to a centimeter, because they're right next to each other, you're just going to multiply or divide by 10. If I had 3 centimeters, that would be 30 millimeters. If I had 30 millimeters, that would be 3 centimeters. Okay. Now, the next step in terms of our length is going to be from centi to the usual our base unit, our meter. Now, as you can see there, we're stepping over deci and going straight to the meter. So the reason why a centimeter, we need 100 of these to make the usual meter, is because it's 2 steps, okay? Nothing's changing. It's very much the same as if we multiply by 100, it's times in by 10, times by 10 again. Same idea here. So a centimeter, we need 100 of these to make our usual meter. Finally, then, we have our kilometer, or kilometer, if you will. So how many meters are there, do we think, in a kilometer? Well, in this case, I can see I've got meter to decameter, that would be 10 of them. To a hectometer, it's 100. So to a kilo, it's going to be 1,000. And the nice thing is these words, and you've probably seen a few of them around, they do really help us with the language. Milli always means 1,000 times smaller than. So it's 1,000 times smaller than the base unit. Cent always means 100 in per cent, in a century. How many cents are in a dollar? It is 100 times smaller than the base unit. So I need 100 of them. Kilo is always 1,000 times bigger. So if you think about a kilogram, well, I'm going to have 1,000 grams in. If it was a kiloliter, it'd be 1,000 liters. Kilometer, kilometer, 1,000 meters. So this is the general idea of how this works, okay? Now, the main thing with the metric system for functional skills is they like to include this and involve this with our kind of area and perimeter volume questions. So it's really important that we're very comfortable with this, but also that we're very happy to kind of spot these straight away. The nice thing is, with their use of metrics, they can actually they can kind of give quite a lot of the question away right at the beginning, which is very, very useful. So what I want to do, we're going to have a look at a problem. Now, I'm not actually going to pause it and give you guys time to work through it, because I'm using it as an example to just help you to digest and get through some of these bigger area questions, which cause a big problem for a lot of learners. So the main things that we want to do whenever we look at one of these questions, if it's one of those 4, 5, or 6 mark questions, what we want to do, we want to look at that. We'll immediately pause. We want to read the question, okay, before we even attempt to answer it, so that we know what's going on. We've got more than enough time to do that. And then we want to ask ourselves these 2 questions. First of all, what is it I need to find? Is it an area, perimeter, volume, or surface area? Then what we want to do is look and think, are the units the same? A lot of the times they will give you maybe a conversion, a ratio to use. So it might be that the picture is in inches, and then down here it will say there are 2.54 centimeters in an inch. So that will be one of the next steps to convert from centimeters to inches. So this is a conversion of imperial to metric. Any of these, they will give you that information. Okay, you don't have to remember that. I will show you exactly what you need to remember in just a second. But sometimes having a look and seeing, oh, well, that's in millimeters, that's in centimeters, it can be a really, really useful thing to actually, it can help us a lot and give us a very clear starting point. Okay. So here is the question that I want us to have a little bit of a look at then. So what we have here is George is going to cover part of the floor with tiles. Now the part of the floor is in the shape of a triangle as shown. George buys tiles in packs. Each pack will cover 1 meter squared and costs £39.95. The tiles can be cut and joined, and George will get 1/3 of the total cost of the packs of tiles. Sounds like there's a lot. Again, what we want to do, we just want to pause and we want to bullet point down the steps that we need to do to solve this. The first thing that I'm going to do is I'm going to check those units. Okay, it's the easiest and most straightforward. Those two little rules that I just mentioned. First of all, what is it I'm finding here? Well, the thing that gives that away is this. We're talking about meters squared. Any squared unit is an area. So I now know immediately, right, I can focus in. This isn't a volume question. It's not a question about perimeter. It is about area. Are the units the same? Well, as we can see here, I've got centimeters on my diagram and my tiles are in meters. So that tells me my first step. A lot of people can get very lost with these questions, but just knowing this first step is going to be absolutely spot on for generating you that first mark. It's going to really help build your confidence in spotting where all the marks are for these types of questions. So the first step is going to be, okay, I need to convert my units. Okay. What I'd recommend is, again, write this down in your own words. It means that you're going to have paid more attention to it. You've got more of a semantic link. You will remember this even more. So we need to convert the units. I then know I need to know what's the area of the triangle. Okay, so I need to work that out. And then it's a simple case of, well, how many packs do I need? What's the cost? Oh, he's going to get 1/3 off. So what's 1/3 of the cost? And then finally, 1/3 cost taken away total. So you can already see there, again, I've just rewritten, and very, very quickly as well. You've got more than enough time to do this. I've just written down each kind of individual step that I need to do to tackle this. It makes my life so much easier. It means that my brain, I'm not trying to remember what the next steps are because I've written it down. It's like a shopping list, okay? It's written down, we're ready to go. So first of all, I need to convert these units. That's 305 centimeters. If I'm converting that into meters, then it's going to be smaller because meters are bigger measures. So this is going to be 3.05 meters. And then the base there is going to be 3.715 meters. Okay, all these other steps we're quite happy with. Okay, the area of a triangle, we know how to do this. We do our height times base. So 3.05 multiplied by 3.715, which gives us a very large looking number there. So we end up with 11.330. So bad light in here, 0.75. So that would be the area of a rectangle there. As we're aware of, all triangles are half a rectangle. So we're going to divide this by 2. And then we get our answer there of 5.66, 5375. Don't be put off by the long numbers. At level 2, it's very rare that you're going to find really nice even numbers. Okay, well, this is in meters squared. And we need to know, well, how many packs do we need then? So hopefully we're quite happy at this point. Well, if it's 1 meter per pack, I need 5.665375 exactly. this is where we're going to use logical rounding. If you go into a shop, it's very uncommon that you can say, excuse me, I need 5 whole packs, and then can you get me 0.665375 of a pack? They won't do it. We need 6 of these packs, okay? Okay, so what's the total cost there then? So the total cost in this case, all we have to do, well, I need 6 lots of these, and each one is 39.95. So it's 39.95 multiplied by 6, and that's going to take us to our answer. So 6 times 39.95. That is going to be 239.7. Absolutely perfect. So at this point, we know the total cost. We've just got our final step, which is that there is going to be a 1/3. So he gets 1/3 off. Okay, so it's always important to read these fractional questions. Sometimes it might be he will only pay 1/3. So that would be what's a third? That's what he pays. In this case, it's 1/3 off. So we need to do this divided by 3. To get our answer there of £79.90. And then our final answer there then is going to be our 239, take away this extra £79.90. Let me just pop that in, 239.7 minus the answer, and we will only have to pay £159.80, I believe. It looks like there's a lot in there. The main thing I wanted to highlight there is that by it saying meters squared, it gives a lot away. It's very common that they put this unit conversion right at the top. So that's another really important one for us there to highlight. The other thing I'm going to very quickly highlight as well, I'll leave that working out there very quickly for you, is this bit of wording here, okay? Because you would have seen this in some of your area questions now, okay? This bit here, where it says the tiles can be cut and joined. So the tiles can be cut and joined. Maybe the skirting boards around the room can be cut and joined, and so on. So all this means is you are the builder, you are not, you are the architect and not the builder. So all you have to do in terms of this is just think, okay, I'm just telling them how much they need. It's up to them to build it. It's up to them to kind of get the tile, break it in half, and make it fit here and here. Okay, I don't have to do it. I'm just telling them exactly how much they're going to need there. Okay. So very, very quickly then, just so everyone's happy with this, I just want to highlight what the main metric measures are and what you need to definitely remember. Okay. You need to know that there are 10 millimeters in a centimeter. Okay. This one's quite easy to remember. Hopefully that diagram, you can imagine it just being one step there, but also you're going to have a ruler in your exam, so you can remember this one nice and easy. Okay. The second one is that there are 100 centimeters in a meter. So cent always means 100. So again, this one, hopefully that helps us to remember 100 centimeters in a meter. The final one then, and this is for our length measurements, is that there are 1,000 meters in a kilometer. So kilo, the prefix, will always mean 1,000, okay? So this applies for our metric measure of weight as well in terms of grams. So 1,000 grams will be 1 kilogram. The final one we have is milliliters to liters. So what you might spot there is, well, milli always means 1,000 times smaller than, and we're going from here, we're missing centiliters and deciliters, and we're going straight to the main unit. Again, you might just, this one's quite an easy one to remember because it's really ingrained into our culture in terms of, if you think about the different cans or different beverages that you might drink, you know, can of Coke, 330 milliliters, bottle of Pepsi, 500 milliliters. Slightly bigger bottle, Fanta maybe, let's mix it up a bit, you got 750 milliliters. You never see a 1,500 milliliter bottle. It then switches to 1.5 liters. So these are the ones that you have to be able to remember. Now, there's 2 ways of how you can kind of view this. If you know what one is, then that's always going to help us, and we can always spot the pattern. If I know what 1 centimeter is equal to 10 millimeters, if I have if I want to convert this to 8.4 centimeters, let's say, then I know that I just need to increase this by 8.4 times. Okay, so it's like having that base unit of a percentage, essentially 9.1%. The other way that you can view this is just look at the base pattern. Whatever you have in centimeters, you will always have 10 times more millimeters. So this is where that ability to just very, very quickly multiply by 10, 100, or 1,000 comes in. It's the better way to view these. If I know how many meters I've got, what's the link with centimeters? Well, there's always 100 centimeters in a meter. So if I have 5 meters, I've got 100 times more centimeters. If I had 5.6 meters, I've got 100 times more centimeters. So it's just spotting these little patterns there. But this is what we need to remember. I mentioned about the imperial measures. These are, they might be mentioned in terms of inches, feet, yards, pounds, but you will be told kind of how to deal with them, essentially, or you'll be given a ratio to switch between them. Okay, so a couple of practice questions for you then, if you can have a quick go at these, and then we're going to get moving on to our first topic, which is our talk about speed. Josh, yeah, first two, absolutely perfect. Same for number 3 there. That's brilliant. Melissa, yeah, absolutely brilliant. Really nice start there. It may be as well, just to highlight this as something, some of this you might know all of this. You might already know this, not a problem at all. If you work with measurements a lot more often, a lot more frequently, then this is like, you probably don't even have to think about this. For some people, though, they don't do that as often, and I want you to be aware of exactly what level of maths is being tested here. Some of it you already know, you will find it easy. That's fine. Okay, don't think, oh, it's too simple, they're trying to catch me out. Sometimes you will just instinctively know this. Okay, Astra as well, no problems there. Josh, you're fine with number 4 as well. Okay, this is looking really good, guys. So absolutely spot on here. Okay, what I'm going to do, I'm just going to pop a couple of these answers up then. And again, there are multiple worksheets for this on the Google Classroom as well. And there's with skills like this, it is really a case of practice makes permanent. Okay, the same as our circle formulas. We have to be able to remember the area of a circle and the circumference of a circle. There's not too much more that I can do in terms of these sessions apart from give you the formulas, explain how they work, and up to you to keep practicing it and find ways of remembering. Same with the metric measures. You just need to practice it, get really, really comfy with how to switch between these. So 4 meters into centimeters. So this is going to be 400. Again, just imagine that base unit there. Okay, well, for every 1 meter, that is 100 centimeters. So this is going to be 4 times as many. Tina, yeah, absolutely perfect as well. What I'm going to do in this case here, I'm just going to pop these answers up very quickly because I can see everyone's got this correct. So yeah, absolutely perfect. Grams to kilograms, there are 1,000 grams in a kilogram. So we are going to essentially just divide this by 1,000. That's probably the easiest way, is to look at the links there. Well, for every kilogram, that is 1,000 grams. So I can just do a division of 1,000. Centimeters to millimeters, well, centimeters are bigger measures. So when I go to millimeters, it's a multiple of 10. Is it a multiplication or a division? Well, there will be more millimeters because they are smaller measures. So little things that can help you remember there. Our last question here, this is more of a level 1 style question, but let's say Shay says that 1.5 kilometers is less than 1,400 meters. Is she correct? Explain your answer. So you could argue this either way. You could say, well, 1.5 kilometers is 1,500 meters. That's a fact. That's 1 mark. So she's therefore not correct. You'd probably want to maybe very clearly state as well, 1,400 is less than 1,500, essentially. You could do it this the other way, though. You could say 1,400 meters is 1.4 kilometers, which is less than. And then either way around, we've got the answer there. Okay, so we're going to have a little bit of an introduction into compound measures, and we're going to kind of derive our kind of our formula for our first common measure here. We're then going to look at one or two questions regarding this. Then we're going to take a little bit of a break, come back, practice a few more before we move on to our last metric, our last compound measure. So a compound measure in itself is just a measurement of two or more different units. Tends to just be 2 units, okay? They can be imperial, they can be metric. What I mean by this is, let's use our most common example, which is speed. In England, this is measured in miles per hour because we are still insanely behind on the idea of switching to metrics for some reason. Pretty much anywhere else in all of Europe, it is going to be measured in kilometers per hour. So it is still a measurement of 2 things. It's a measurement of miles, a distance, and hours, a time. So it's essentially just quite simply put, how far have you gone in this amount of time? It tends to be per hour. You know, how many miles have you gone in an hour? I've traveled 60 miles in an hour. I've therefore done 60 miles per hour. Quite nice and straightforward. Now, there is another compound measure, which is called density. And we will talk about this a bit more later because, again, the wording tends to kind of give people the shivers a little bit when they think about, you know, density, mass, volume. It all sounds very fancy, but I will explain this a bit more later on, and you're going to feel very, very at ease with it. The main thing we need to be able to do is, for functional skills, we need to be able to calculate speed, and we need to be able to rearrange the formulas for this. So for speed, we need to be able to calculate a speed, a distance, or a time. For density calculations, we only have to work out what is called a mass or a weight. I will explain more about this moving forward. Okay, what I want you guys to do is very quickly, please use a calculator. I want you just to have a go at these questions, okay? And this is going to help us to derive our first formula, because we deal with speed very, very commonly. You're probably aware of this without even looking into it. The main question that I kind of want to focus in on is question 4 as well, because we tend to get a few different answers for this, which will lead me neatly onto our next kind of slide about decimal time. So have a little bit of a go. Let me know what you think here. So we've got a car is traveling 70 miles per hour. So just think that is a compound measure. It's 2 measures put together. Per in itself always means divided by or out of. It's how many miles have you gone out of the time frame. So if we have a look here, yeah, Josh, you're off to a great start there. And again, if it seems too simple, it normally is. Okay, please don't worry, you're absolutely fine here. Have a go and see how you get on there. Wow, look at the speed of that, guys. Yeah, Josh, those first 3 absolutely fine. I mentioned question 4. I'm not trying to trick you all. Most people will tend to get this one right, but this is the question where there are normally kind of 2 variables there. Okay, yeah, Tina, they are all perfect. Astra as well, those first 3 are absolutely perfect as well. So I'm going to start going through these kind of ideas. And again, I'm only really using this slide as a bit of an introduction to the idea and the concept. Melissa, yeah, I can see you've got that one there absolutely spot on as well. So that's for question 2. Okay, so the idea of this exercise was just to kind of get you thinking a little bit. Now, the first 2, most people will just kind of instinctively know this straight away because it's halving and doubling, isn't it? If a car is traveling 70 miles in an hour, how far will it go in 2 hours? Well, it's gone double as far, hasn't it? If it was going 70 miles in 1 hour, in 2 hours, it's gone 140. You can view it as a ratio. We know what 1 is. If we're talking about half an hour, it's the same kind of concept here. If it's 70 miles in an hour, but now it's traveling half the time, it's gone half the distance. So this is how we get our 35 there. Now, when you put this into the idea of, well, how far would it go in 5 hours? This is where most people really do kind of spot and derive the formula. Well, how far does it go in 1 hour? So that's its speed. And it's doing 5 lots of that. So lo and behold, and this is what you were doing from the beginning, but now we have derived our formula. So all we do, if we know how fast something's going and how many lots of time we need, we just multiply speed and time to get our distance. So in 5 hours, it would travel this far. If it was traveling at 70 miles per hour for 12 hours, we would just multiply it through by 12. So quite nice and straightforward. So we've derived our formula here, and we're going to expand on this a little bit in our next slide, because we need to know all the different variations of this, okay? But I will build on this a little bit more in the next slide. Now, the only one that is a little bit interesting here is this 4.3 hours. Now, everyone's got this one correct in the group, but this is one of the things I wanted to kind of highlight in terms of why some people can have a little bit of a problem with this. So the idea here, with it saying 4.3 hours, that sounds a bit strange, doesn't it? Because we tend to talk about hours in terms of hours and minutes. So that's why half an hour doesn't stand out as strange to you, but 0.3 of an hour does look a little bit weird. We know that the time is the same, and actually this is 4.3 of an hour. So how we would put this through is just multiply it by 4.3. The distance is going to be the exact same there. And we'll look at why this happens in a moment, but essentially we've got a speed, which is miles per hour, so miles divided by hours, and then we're going to multiply this by time. So what we do with our numbers, we do the same with the units. This unit here, speed, is miles divided by time. Hours, that's in time. If I divide something by time and then I multiply it by time, I'm just undoing what I've done. So that's why our distance will end up in just miles there. Just a little bit further explanation. You're not going to get asked any extended questions on units, so please don't worry. Now, it's very common that a lot of people look at this question and they will put this into their calculator. The reason they do this is, at a glance, people see 0.3 of an hour and they think, 0.3 of an hour, that is going to be 30 minutes. It's not the same thing. We'll expand on this in just a second, but this is where there's a bit of confusion with time. It's because time is a hexadecimal. It is out of 60 and not out of our conventional kind of tens or hundreds. But these are all the answers there. We have now derived our formula. So what we can now do is make this even easier. So like I mentioned previously, you will need to be able to derive either a distance, a speed, or a time. Now, when I was in school, unfortunately, we had to just remember all 3 of them. We can work this out. If we remember this one, speed times time is distance, we can use our reverse calculation skills to work out the others. Well, that would mean if I go from the end, that would be, well, distance divided by time will give me speed, and distance divided by speed will give me time. We can look at it this way. It's a bit harder to remember. It's extra information. We don't actually need it because what people have come up with is what is called a formula triangle. Now, these are absolutely beautiful. What they do is they just give you a quick and easy way of remembering these 3 formulas in one thing. So they make it simpler for you. What you have to do, you need to draw this triangle, and then you are going to, essentially, you cover up the thing that you don't need, but we'll look at how it works in just a second. The important thing for you is that you need to remember this triangle. Yes, you can get through some of the problems without it. You know, if you apply a bit of common sense, a bit of logic, you can view any of these problems like a ratio, but remembering this triangle makes it 10 times easier, okay? And you feel a lot more confident with it as well. So the main thing that you want to be able to do here, we have to remember that distance is always on the top of this triangle. Speed and time are on the bottom, and they can be written either way around. We have to remember the components, speed, distance, time, and we have to remember that the distance is on the top. Now, I've heard some really good ways of people and how they remember this. I would only kind of advocate more than anything, make it creative, have a sense of humor. Okay. If you do this, you're going to remember these measures a lot easier. Okay. And you're going to remember these things a lot quicker. Someone mentioned about the ST here, reminded them of a striker. The D stood for a defender, so and then up here you had the goal, so the goalkeeper. Got your striker, your defender, your goal. That's how they remembered the ST, D, and then this. Some of the medical staff pointed out that actually, in terms of letters, you have got STD there. So their kind of ideas and knowledge of STDs has helped them to remember, where all this is on a triangle. There's lots and lots of different ways of remembering this. You could come up with a bit of a slogan. I don't know. Sean doesn't tiptoe. I don't know. Whatever it might be, the more creative you make it, the nicer or easier it's going to be there. Just so you're aware as well, in terms of units, these are some of the more common units, but they can be different. So distance is always a measurement of a measure. So this will be kilometers, miles, meters, etc. Time is always going to be either in hours, minutes, or seconds. It can only be in one of them. That's the idea. With time, it has to be in either hours or in minutes or in seconds. Just as kilometers, it's got to be either kilometers or meters or miles. It's got to be just one. You can't say, 3 kilometers and 300 meters. You have to convert them all into the same. The speed is then going to be a mixture of these. So it's how many kilometers per hour, and it's whatever these units are which determine, okay? So if this was miles per minute, then the speed would be in miles per minute, essentially, as well. Okay, so how does this work then? So in terms of how this works, all you have to do is cover up what you don't want in the triangle, and it will tell you the sum for the remainder. I'm just going to draw one more triangle because it makes it kind of easier for some people to spot. You can actually draw some of the additional kind of information on here. So I'm going to put S, D, and then D. What I do sometimes is I just put these two little dots here and a little cross here, and it tells me exactly what sum I'm doing as well. So in this top example, let's say I've got a problem and I need to know the time. A car travels 50 miles per hour and it travels 50 miles. How long did it take? If I cover up time, it tells me the sum. It is distance divided by speed. So I cover up the thing I'm looking for. If I cover that up, distance divided by speed, 50 divided by 50 is going to be 1. So it took 1 hour in this case as an example. Okay, let's say I needed to find the speed of something. Okay, so, George needs to cover 100 miles in 1 hour. How fast does he have to travel? Well, I can look there again. I've covered up speed. It tells you I've got to do distance divided by time. 100 miles in an hour, 100 divided by 1 is still 100. So he'd have to travel 100 miles per hour to accomplish this. The final one then is just if we cover up distance, and this is why speed and time are interchangeable. You could write it T then S, or you could write it S then T. Doesn't matter. Because when I cover up distance, and this is the formula that we already know, we have to do time multiplied by speed. So in this case, let's say we need to cover a distance, or someone travels 50 miles per hour and they do this for 3 hours. How far have they gone? Well, it's 50 miles per hour and they're doing it for 3 hours. So therefore it's 50 times that. It's going to be 150 miles in total. Okie dokie. So these are our kind of units here. Now, the only thing we're going to have a very quick talk about is the idea of decimal time. And then we're going to have a little bit of a look at one or two of these questions before we take a nice break there, because I know it's been a little while. Okay, so the problem that we have is conversion with time. Now, the French did try and decimalize time. They did for a few years during the French Revolution, which is amazing. Unfortunately, it didn't catch on. And we still use the old system, which is out of 60. 60 seconds in a minute, 60 minutes in an hour, and that's our time. So the problems that we have is if you try and put in a lot of sums into your calculator, pretty much everything in our calculator, it works on a decimal system. It works in terms of ones and tens, essentially. So trying to put in measures of time, especially in decimals, it can be a little bit confusing. I'll show you an example of this in just a moment. So the best way around this is switch to a decimal time. There are basically two solutions. You have a problem, you either convert to convert everything into hours, and then you get to your answer, or you get to your answer and then you convert the time back. Either way, but we have to do a bit of a conversion of time. The problem is we have hours and minutes very, very commonly. So if I give you an idea here then of a few of these kind of decimal times and why these can be useful. So if I had 1.5 hours, I could write this as 1.5 hours. Okay, 0.5 always means a half. Why is this? Okay, well, in this case, it is 1.5 an hour. Half an hour is 30 out of 60. The hour is 60 minutes. This is 30 out of 60. If I simplify this fraction, it is 1/2, which as a decimal is 0.5. Okay, the same as, well, 30 minutes. What would this be? Commonly, and again, this is where our language can really help us, we would say, well, half an hour. Half an hour, half is 0.5. It is half of an hour, and there are 60 minutes in an hour. So 30 over 60. If you type in that sum, 30 divided by 60, you get 0.5. Same with the top. 1.5 hours. Well, 1 whole hour is 60 minutes. So if you typed in 90 divided by 60, you get the same answer. 45 minutes. What would we commonly call this? And this is the one that tends to kind of get people a little bit in terms of where we put our point. Well, 45 minutes, that is, if I imagine a clock, that's 3/4 of an hour. So I'm liking that someone's already popped the answer across it. Yeah, Josh, absolute hero, buddy. So this is 3/4 of an hour. That's how we would say it. 45 out of 60. If you complete the sum, 45 divided by 60, you're going to get 0.75. So that tells me that 15 minutes, so 15 minutes is going to be 0.25, okay? Some really simple trap that a lot of people fall into, and that's why I wanted to highlight it. A lot of people look at this and, they'll see something where someone travels for 1 hour and 15 minutes. So they type it into their calculator as 1.15. It's not 0.15, okay? It is 0.25 because 1/4 of an hour is 15 minutes and 1/4 is always 0.25. So you can see the same kind of idea here for question 4. Okay, well, how many hours and minutes would this be? You can just divide it by 60 and it will switch it straight away for you. But sometimes it's easier to see it as taking out 60. So it kind of just makes our brains feel a bit nicer sometimes. In this case here, 135 minutes, well, I know that is that's 2 whole hours, and then I've got 15 minutes left over. If I wanted to write it as a decimal time, I would say, well, 2 hours, 15 minutes, 15 divided by 60. Yeah, that's 1/4 of an hour, so 1/4, 0.25. And for these last two here, you can just divide them through by 60, and that's going to switch to the answer. Now, you're probably thinking, what is the point? Why is this useful? Why is this anything I need to know? What I now want you to do is have a go at question 7, okay? And I'll show you both of the solutions of how to do this. And again, you might interchange between them, but I just want you to have all the tools to essentially do this. So we've got speed is distance over time. So you need to use this formula here, okay? You'll have to cover up one of these to find out what sum to do. Now, there will be 2 solutions. What you're going to have is the problem. So in this case, we have we need to calculate the speed. So we can either go, when we're calculating this, we can either have the sum that we have. Let's say I'll just put I'll just put a little S in there. So we have the sum. You can either kind of convert. So I'll just write in here just so it helps a little bit. You can either convert time and then you get to your answer, or you can go to your answer and then convert the time. Either way you choose to do this, it's absolutely fine. It's just two different routes to get to your overall solution, okay? So just a little bit of a diagram there to help, but have a little bit of a go at this one. Let me know what you think. Pop over some answers, and then we will go through in just a second, okay? Astra, yeah, that's absolutely fantastic. Spot on there. If you don't mind, if you could whoop whoop, if you could send me over a message as well. If you could just show me the sum that you've done there as well. It's just for me, it would be interesting to see which route you've taken because people tend to either complete one route or the other. I will show what the answers are for both, but yeah, just for my own kind of interest there. Okay, perfect. So you've gone with switch to the decimal hour, and then you obviously get your answer there. Sometimes it might be that you can't do one of these systems. It might be that you can, potentially solve it in. You might not really be able to use a decimal time. You can always use both, but it might be more difficult. I'll just give you another minute, and then we will go through and kind of talk through this one. If you're a little bit lost as well, please let me know, and I can obviously kind of slow down the explanation a little bit further if we need to. Tina, yeah, absolutely fantastic. Great work there. Okay. I'm going to start talking through this one. I want to show you where the marks would be awarded for it and how we're going to solve this. So first of all, we've got, let's work out what it is that we're trying to find. So Brian rides 22 kilometers in 2 hours, 45 minutes. What is his speed? Trying to find speed. So if I cover up speed, I have got distance over time. Now, even just for writing that, that's probably going to get me 1 mark there. These tend to be 3-mark questions, but they can obviously improve on them or increase on them. You'll see more about the style of these if you look on the classroom assessments as well. So we've got distance over time is equal to speed. Okay, well, what is our distance? Our distance is 22 kilometers. Now, what is our time? It's 2 hours, 45 minutes. So the problem that we have is I've got 2 units of time. I can't have 2 units of time because then it means that my answer will be in kilometers per hours per minute. It doesn't work. So what we have to do, we have to make a choice at this point. We either convert everything into minutes or we convert everything into hours, okay? So I'm going to choose, first of all, to convert this into hours. If I want to do that, then I'm going to have 22 kilometers. I'm going to divide it by 2.75. Now, the reason it's 0.75 is because 45 minutes, so this is why it's not 0.45. This is what gets a lot of people. It's not 0.45 because it's not on a scale of 1. It's on a scale of 60. So imagine 45 out of 60. If I put that in, that is 3/4, it is 0.75. And if you put that in, you're going to get your full answer there. It is 8 kilometers per hour. You don't have to worry too much about the units, but understanding where they come from is very useful. We know that our distance was in kilometers, our time was in hours. So therefore, what we've been given here is our answer in this as well. So this is probably the quicker and easier of the two, and this is when they tend to give you these problems, they like to use 15 minutes, 45 minutes, 30 minutes, things that we're quite common with. Now, there is no reason you can't do this the other way. You can say 22 kilometers, I'm going to divide it by 165 to get my answer. Okay, why 165? Well, there's 2 hours, that's 60, and then another 60, so that's 120. Add the 45, so that's 165. Now, if I type that in, 22 divided by 165, I'm going to get my answer here. And the weird thing is, although it looks very strange, it's not incorrect. Okay, so the answer we get here is 0.133333 recurring. Whenever we see recurring numbers, we tend to kind of shy away in fear, but you might get them at functional skills level 2. Just view it as a 3-digit number. Okay, just go to 3 decimal places if you need to and view it that way. Now, what are the units here? We've switched to minutes. So this isn't kilometers in an hour. This is how many kilometers you go every minute. Obviously, there's a lot more minutes in an hour, so we're not going as many kilometers. So that's why, so this is going to be in kilometers per minute. In the top question, what we've essentially done is we have done 2 hours 45 and we've switched it all into hours. We essentially divided, well, yeah, we've essentially kind of multiplied through by 60 or divided through by 60. In this case, we're going to get the answer and then we're going to switch it. So I just need to go from minutes to hours. To do that, I'm going to multiply by 60 and this will take me to the exact same answer. It's entirely up to you how you do this. You can switch to minutes and then when you get a strange looking answer, multiply it by 60. Absolutely perfect. Or you can go and switch it into hours first of all. It might be that you prefer one route on some occasions, some route on another. That's absolutely fine, okay? But this is the idea of why this decimal conversion or conversion of time is important. Main thing is if you can remember this triangle and use it, that's going to get you the majority of the marks there. Okay, so we are going to take a break, but what I'm going to do, I'm going to leave these questions up here so obviously people can have a little bit of a look through. Obviously, if you come back from the break a little bit early, you can have a little bit of a look there. We'll take a quick, just 10 minutes or so, if that's okay. And then we've just got 1 or 2 more of these questions in our final topic. So it'll be a little bit of a shorter session in regards to that. So if everyone can be back for 1:15, that'd be absolutely fantastic. And then we can go from there. Okay, so we've had a little bit of time to have a look at some of these problems. So let's have a little bit of a think and see how we deal with these. So for question 2, then we have got a car travels at a steady speed. So again, that just means we're not calculating acceleration or deceleration or anything like this. So travels at a steady speed and takes 5 hours to travel 310 miles. What is the average speed? So again, to do this, we want to cover up speed. So we've got distance over time. So the sum that we're going to have is distance divided by time. The distance itself is 310 miles. The time taken is 5 hours. So we should end up with an answer of 62. It is the distance over time. So just remember that line there. If we're using the distance at all, it is always going to be distance divided by something. Okay, distance is always on the top there. So a plane flies 1,400 miles at a speed of 240 miles per hour. How long did it take? Okay, so how long? That is a time frame. So let's cover up time. Now I've got distance over speed. Distance divided by speed. Even just for writing that again, we're probably going to get 1 mark there. The distance here is 1,400 because that is miles. The speed is in miles per hour, so that is 1,400 divided by 240. And we can see here it's going to be 6 hours. We know this because we've got miles, and then it is miles divided by miles per hour. So it ends up, these kind of units cancel out, and we end up with just our time remaining, essentially. A marathon runner runs at 7.6 miles per hour for 3.5 hours. How many miles has he run? So how many miles has he gone? That is a distance. So we're going to cover up distance, and we've got speed and time. Just imagine they're next to each other, just as with any algebraic notation. or even brackets. You know, if we have a number outside of a bracket, it means you have that many of the bracket. So in this case here, we have got you know, S and T right next to each other. That means multiplied together by. So 7.6 miles per hour. So how many miles has he run? So we've got speed times time. So the speed is 7.6. We're going to multiply that by 3.5. And a half. A half, if I want to type it in my calculator, it's these quick conversions that make it easier. I know that a half is always 0.5. You can do it this way. You could change the other way, and you could say, well, 3 hours, that's, you know, 60, 120, 180, and then add the half an hour. So you could actually multiply by 210. The speed you would get would be in miles per minute, though. You'd then have to multiply your answer by 60 to convert it back. It's a lot easier to use that decimal time if possible. Finally, then we've got a car takes 15 minutes to travel 24 miles. What is its speed? So the overall answer here should be 96 miles per hour. And there's a few ways that you can get to this answer. So we know, first of all, we're looking for speed. So we know that our question is going to be distance divided by time. Now we know the distance, that's 24 miles, and the time is 15 minutes. So I can just do this sum here. But the problem that I find is that the answer itself, so it comes up at 1.6. This would be in miles per minute, okay? Because it is the distance in miles, the time is in minutes. So what I have to do here, if I want this in hours, I have to times it by 60, and lo and behold, I get to my answer. You could also view this differently. You might have looked at this straight away and just thought of a decimal hour. Well, 15 minutes, that is 0.25. That's a quarter of an hour, and that will take you straight to 96 there as well. So this is probably the more common method. As a third method, and just to kind of highlight that you can view any of these problems like a ratio. Well, I know, sorry, I know that 15 minutes will get me 24 miles. This is a fact. These things are in direct proportion. What I could do, if I really wanted to, I could divide by 15, and that would tell me how far the car travels in 1 minute. I could then multiply it by 60 because that's how many minutes are in an hour. So that's another way I could solve this. Probably the easier way, though, is just look at the stepping stones. You know, imagine, okay, well, that means logically, if I double the time, I double the distance. So in half an hour, 30 minutes, it's gone 48. So therefore, in 1 hour or 60 minutes, it will go 96 there. So any of these calculations?
So I can see where I went wrong. The one with 62 miles per hour.
Yeah. So did you say you can't quite see where it's gone?
60 minutes, 1 hour. Can you hear me?
So
the question number 2.
Question number 2. Okay.
Yeah, I did get 62, but I thought I checked the car in miles per hour.
Okay,
so I just said 60 is 1 hour. Yeah, I can see what I did wrong. Sorry. Yeah, it's my fault.
No, absolutely fine. But that's the great thing about going through these questions, though. It's because again, sometimes if it is just like a recording sometimes, or just reading it in a book, you can sometimes be getting the answer wrong and not quite see why. So it's really nice to have someone talk through the explanation. But I'm really glad. So has that clicked for you now? Have you looked at it?
Yeah, I went back and thought, oh, 60 minutes. So 60 minutes, 1 hour, 2 minutes. Okay. Yeah. All right. I got it. Thank you.
It'll be it's a useful thing as well to actually kind of spot something or spot a bit of an error like that at an early stage. Just means you're almost more guaranteed to not make it in the future.
Yeah, thank you.
Absolutely spot on there. Okay, so what I've got for you then is essentially we've just got 2 more of these, and then we're going to move on to our final component, which is our mass density volume triangles. So what I want you guys to do is have a go at these 2 questions. I'll just move my face down there. So you've got the speed, distance, time triangle in the top right there. What I want you to do, have a go at question 1. This is pretty similar to what we've been looking at. Question 2 is a little bit different because it comes up with working out a time taken, which can be a little bit confusing sometimes, but we'll expand on this a little bit as well. So just take a minute and let me know when you're ready, and I'll obviously go through the answers for you. Yeah, absolutely spot on there for question one. That's brilliant. So again, I'll give you guys another minute or so on these. So do bear in mind for question one, this would be at least a 3-mark question, potentially a 4-mark question. And you can hopefully you can start to spot with these kind of with these types of questions how they could embed a little bit more to these. Now that you've seen kind of like the vocational element or the wording and what they use in, let's say, the area topics, you can see where they might apply this in here as well. So it might be that we have to work out the distance that someone has traveled, and then we know how many miles per gallon or how many liters per kilometer has been used of petrol. So how much does it cost? So you can see where from a 3-mark question, this can easily kind of build into a 4 or a 5-mark question there as well. Wow, Tina, my hat is well and truly off to you. That is amazing. It's very, very rare that people get the answer for number 2 completely correct without a question mark on the end. Even rarer that people do the extra step of converting it into hours and minutes as well. So if that was a question and it asked you for hours and minutes, that would be a 4-mark question. You've absolutely nailed it. So massive, massive well done there. That's awesome. Josh, yeah, spot on for number 1 there. So I'm going to start going through these. Please bear in mind that you would have more time for these in the exam. I'm going to start going through this. So actually, yeah, so the answer you've got for number 2 isn't incorrect. It's just thinking, what is 0.33333333? Think about it as a fraction. It's a third. So how many minutes would a third of an hour be? So I'm going to go through and expand on that in just a second as well. So let's have a look at question 1 here then. So for question 1, we should get 53.6 as our answer. Now, the reason for this, we are looking for an average speed. If we cover up speed, we have distance divided by time. So the distance is 335, and the time here, where is the time there? And the time is 6 hours and 15 minutes. Now, again, you could convert all of this into minutes if you wanted to, 6 times 60, and then add on the 15, then convert it back at the end. But hopefully now you can kind of spot it's just a bit more work, you know? So in this case, 6 hours and 15 minutes. 15 minutes is a quarter of an hour, and a quarter is always 0.25. So if I type in this sum, that will take me straight to my answer of 53.6. Very common that people might put in 0.15. Okay, just remember the reason it's not 0.15 is because we are converting as a fraction. It is quarter of an hour. An hour is out of 60, not out of 100. If it was out of 100, then it would be 0.15, as when we convert from a percentage to a normal number or to a decimal. But in this case, it is 15 minutes out of the hour. 15 out of 60. If you complete this sum, if you simplify it, it is 1/4, which is the same as 0.25. Okay, it's a really common one to use that 0.145 there. Sorry, 0.15 instead. Okay, I'm getting some absolutely amazing answers for question 2 as well. So the answer that most people are coming up with then is 3.333333 recurring. So obviously Tina, they went absolutely brilliant work on converting this. Let's have a look at kind of how we can answer this. Now, the question itself says Michael decides to go for a ride. He rides a distance of 80 kilometers at an average speed. How long did it take? Now, it doesn't tell us to give our answer in hours or in minutes or in hours and minutes. So you would get 3 marks. If you put down 3.33333 recurring hours, you would get all 3 marks here. Normally in functional skills, they would make this a 4-mark question and they would say, give your answer in hours and minutes. So let's say we're trying to work out a time. So we have distance divided by speed. Now we know the distance, okay, it's 80 kilometers, and we know the speed, it's 24. So the answer we end up with is 3.33333 and so on. So recurring decimals are not as bad in terms of when we use a hexadecimal system, when we talk about things out of 60. The reason being, when we normally see a decimal like a third, that's because 3 doesn't fit into 10 or into 1 nicely, but it fits into 60 very well. So the 2 ways of dealing with this is either going down that logical route and thinking, well, what is 0.33333? I know I've got 3 whole hours, but what is 0.33333 recurring? Well, that's the same as a third. And a third of an hour, I could find this, I could just have 60 divided by 3. So that will tell me that it is 20 minutes. So 1/3 of an hour, again, you can imagine it on a clock now. Oh, it's 20 minutes, 20 minutes, 20 minutes, that's 60. The ways you can get to this answer, and it's entirely up to you, you can type in your calculator. Once you get this answer here, 3.3333, if you multiply that through by 60, it will give you an answer of 200 minutes on your calculator. And you can then see, okay, well, I take out 60, 120, 180, and then I've got 20 left over. So you can do it that way, or you can just realize, well, I've got 3 whole hours. You can just type in 0.333333 times 60, and it will tell you it is 20 minutes there. Yeah, that's a really, really good point, actually. And I will highlight that as well. So thank you very much for mentioning that, Josh. So now, with some calculators, this is going to be a little bit different. If we are dealing with 0.33333, so this final sum here, now some calculators will have, you can actually type in a recurring decimal. So if you have a scientific calculator, you can actually type in 0.3 and you can put the little dot on top of it. So it knows it's recurring. So when you multiply it by 60, it will say immediately 20, okay? Now, on some calculators, it won't do that. What it will do is it will use as much memory as it can, and it will give you an answer as accurately as it can without rounding it or without realizing what's happening. So maybe on a simpler calculator, it will, or, you know, even if you type in 0 point and you put maybe 5 or 6 3s in there, it might just think that you just want that many 3s multiplied. So you won't end up with 20 minutes, you'll end up with 19.999998 minutes. With that, we just have to take it with a pinch of salt and go, right, okay, it's a third. We're trying to convince it, like convert it to a whole number. That is 20 minutes. If you were to think, if you put more 3s in there, that pattern would exceed and continue. I'd recommend, if you are converting that way, is just to actually put 0 point and just type in as many 3s as you can, then multiply it. You should be absolutely fine. But just so you're aware of that as well. Really, really good question as well. So someone's mentioned about the units as well. So in terms of units, it tends to be similar to, when we talked about area. If you're getting the right numerical values, you're going to get the majority of the marks here. It tends to be that with area questions, we find an area and then we have to find out how many packs of tiles or what is the total cost or whatever it might be. So actually using the units, you're not going to gain or lose very many marks. The same here, most of the time they will kind of state the units for you in the answer box. Or it might be that the actual question will be, will they make it on time? Or are they correct? So even if you don't write kilometers per hour or miles per hour, you're still going to get the marks there, okay? So don't worry, if you don't put the units, you're not going to, you may potentially lose 1 mark, but it's quite rare that that would occur. Okie dokie. So let's move on then, and we need to talk now about our second compound measure. So there are some extra questions here if you want to look. Our second compound question or topic is about mass, volume, and density. Please don't worry. I know most people immediately look at all 3 of those words and they go, no. Okay, we've seen volume before. Absolutely fine. Density and mass, these can be a little bit confusing. Now, mass, for all intensive purposes, for us at Functional Skills Level 2, mass means weight. We've seen that word. We know what that means. That's in kilograms, stone, pounds. How much does something weigh? We know that, okay? But don't be put off by mass. Technically, there's a difference in terms of relation to gravity or not gravity. We don't have to deal with that, okay? Mass means weight. So what we have then is a weight and a space. Now, we know what both of these are. We know that a weight is in kilograms. We know that a space or a volume is always in cubic measure. So we can assume, well, if it's a compound measure, it's a mixture of the two. So density is a mixture of these two things. It's how much weight is there in this much space. That's all it means. We don't see it as commonly though, so it's a little bit more difficult to work with. The problem that we have with these is that most of the time, this formula is added on at the end of a volume question. And this is what tends to lead to these 5 or 6 mark questions. You have to find a volume like we would with any area question or volume question, but then we use the volume with the density to give us a weight. Then we have to work out a cost. It's something like this. I've got a few examples so you'll know exactly what I'm talking about. Now, just so people are aware, in terms of density, what this is, you know, if I were to ask you what weighs more, a ton of feathers or a ton of bricks, most people have probably seen this before. They're very happy to get, well, they both weigh the same. They both weigh 1 ton. Okay, you're completely right in terms of which mass is more. If you were to put this in the context of density, then what you'd be talking about is maybe which would float, a ton of feathers or a ton of bricks. If you imagine a brick on its own, 1 brick in the ocean is going to sink. But all of these feathers, any feather, if you drop it, it's just going to sit on the water. Why? Well, obviously you have surface area, things like this. The main reason is density. A brick is more dense than water, it will sink. A feather is less dense than water, it will float. So what this means in terms of what density is, as much as you can see it like this, you know, the more dense an object is, the more it will sink in a liquid or the heavier it is. It just means it has more weight in a smaller space. So therefore, the bigger it is, the more it weighs in comparison. If I give you a little bit of an idea before we go on to these formula triangles, let's just say if I have, and we know that whenever we're measuring something, it is always in cubes, isn't it? When we talk about volume. So let's say I've got this 1 cube here, so it's I don't know, let's say it's 1 centimeter high, 1 centimeter long, etc. And it weighs, so let's say this 1 centimeter cube, let's say that it weighs, I don't know, 1 gram, okay? So the answer here would be, well, how many grams per centimeter cubed does it weigh? Well, if it weighs 1, then that means if I had 5 centimeter cubes, it would weigh 5 grams. If I had 15, it would weigh 15 grams. Now, it's very common that these obviously aren't equal to 1, but let's say if I weighed something out and, you know, if I had 1 centimeter, 1 little cube, it weighs 8.1 grams. Therefore, if I have 50 of these cubes, it weighs 50 times as much. That's all it means. So density is just how much weight is there inside inside a cube, essentially. And cubes is a very good way of measuring, just as measuring in squares is a lot easier when we're talking about area. Now, there are some formula triangles for this, okay? You do not need to know them, okay? I'm just going to really emphasize that. You do not need this, and you do not need this. Because this here is always given. In every question, they will say mass is equal to volume times density. It will always be this way around. You don't have to rearrange it. And it will normally, in most questions, we will have to find the volume. And then once we know the volume, we just have to times it by whatever the density is. And then we get our mass. So this is the only question that they ask if it pops up. So if we think about it in terms of compound measures, it's more likely that you're going to be asked a question. It's more likely that you're going to be asked a question about speed. So if this topic does appear, they're going to probably ask you about speed. If they don't, then they're going to ask you about this, but this is a lot rarer, okay? But when it does pop up, they are only asking you to use this formula, and you are always given it. You can remember this. It might be useful in other elements of your life. Yeah, it could be a useful thing to know. But just be aware, mass as a weight is always in kilograms, grams, pounds, whatever it might be. Volume is in a cubic measure, because we measure it in cubes, centimeters cubed, millimeters cubed, yards cubed, whatever it might be. So density, just as speed is how far have you gone in this time, density is how much weight is there in this space. Okay, that's all it means there. Let's have a look at a simplified example of this, okay? So here is a very nice and simplified problem for you before we go on to the mega horrible question to end the session. So Bob knows that this plastic shape has the following dimensions. Okay, so it's 5 centimeters high, 6 centimeters in width, and 10 centimeters in depth. Well, again, those words are interchangeable. It could be 5 in height, the base is 6 by 10, however you want to imagine this. Now, density, plastic has a density of between 0.8 and 2 grams per centimeter cubed. I went with a nice middle number here of 1.5. So the density of plastic is 1.5 grams per centimeter cubed. So how much does this block weigh? So that's the question for you. So you can see it's like a two-step question. First, you have to find a volume, and that's going to essentially get you 2 marks. Then it's just using a formula. You know what the volume is. It tells you what the density is. You put that in, and then the units are just going to be the weight. So don't be put off. So when we find the volume, that's going to be in centimeters cubed. We multiply it by grams per centimeter cubed. Okay, that is then going to obviously give us a unit of mass or weight, which will be in grams in this case. Again, don't be worried too much about those units in particular. Have a little bit of a go, pop me over an answer if you can, okay? And we can go from there. Okay, I've got 2 different answers. Let me just very quickly double check these, but Astra, I think you're spot on there. So let me just look. Yeah, absolutely spot on there. So Tina, yours is perfect as well. Melissa as well, spot on. Okay, so what are we going to end up with here? Well, first of all, we need the volume. So the volume here is going to be 5 times 6 times 10. Again, we're finding the area of the face, okay? The cross section, whatever you want to call it, with a rectangular prism or a cuboid, it's a lot easier. We just multiply all the numbers together. 5 times 6 times 10, we get our volume, 300 centimeter cubes. Now, each one of those cubes weighs 1.5 grams. And again, if you imagine this was worded differently, you wouldn't even bat an eyelid. If someone said, there are 300 centimeter cubes here, well, that's what it's saying. It's just written in a very mathematical format. There are 300 centimeter squares. Each centimeter squares weighs 1.5 grams. As it says here, the density is 1.5 grams per centimeter cube. So then the mass is going to be 450 because it is 300 lots of 1.5. Josh, yeah, absolutely spot on there, buddy. So this is what they tend to ask. We are going to have a look at a question like this on steroids to end our session. Okay, this is a horrible question. It is quite unrealistic and it's bigger than any of the questions that you're going to see in the exam. But it highlights how they tend to go about asking these questions, and that's what I want you guys to practice a little bit. I would really, really kind of advocate or kind of advise you to, after this session, complete the compound measures assessment, but also maybe have a look at the bigger questions topic as well on the classroom. I'll show you where that is in just a moment. Okay. So this is the problem that we have. It's a bit unrealistic, so bear with me. We have got our good friend called Luke Warm. That's obviously his real name. Now, Luke Warm needs to buy and transport iron blocks from a construction site. They all have the same dimensions. A sneeze, essentially. They all have the same dimensions that can be seen below. So we've got this block here, 500 centimeters high, 10 meters by 20 meters. A bit unrealistic, I know. It's a very, very long block of iron there. But these are the dimensions, okay? Luke is only going to make one delivery and he wants to put or wants to load as many blocks onto his incredibly large truck as possible. Luke knows that the density of iron is 0.5 kilograms per meter cubed. Okay, I doubt strongly that value is correct. I've just made it up. And that his truck can safely hold up to 2,600 kilograms of weight. Each block costs £21.60. How much will this cost him? There's a lot of steps there, okay? You've got the formula, as mentioned, up there in yellow. So the mass is volume times density. Pretty much as soon as you see that written, this should ring an alarm bell. We should immediately think, right, okay, I've got to calculate a volume, then I've got to use the density to find a weight, and so on. I would advise massively with these types of questions, go through, write down the steps that you need to do. And again, have a glance at it and just think about units. Think about what am I calculating here? Any question where you see a schematic, be it a two-dimensional drawing or a three-dimensional sketch of a shape, we want to be thinking, is it area, volume, surface area? How about the units? Take a little bit of time. This is, again, this would not be on your exam paper because this is more than a 6-mark question. But just for argument's sake, if it was a 6-mark question, you would have almost 11 minutes to answer this, okay? You've got a lot of time, more than enough time to make that bulleted list that I keep mentioning about. It's the best thing you can do moving forward. Again, imagine if you're going shopping in Lidl, okay? If you go in Lidl, you need a list. If not, you're going to get caught in the middle Lidl aisle. You're going to end up buying loads of pointless stuff and you're going to leave with a hat and some flip-flops. So by making a list, you keep on track. You know exactly what steps you're doing. All of your short-term memory can focus on each task because you're not worrying about forgetting what to do next. You've already recorded it. Take a couple of minutes to let me know. If you want to send over your answers in pieces, that's absolutely perfect. I can hopefully kind of help build your confidence a bit there. If you have no idea, let me know as well. It's a horrible question, okay? But these are what we want to get used to so we can increase our confidence. Wow, Astra, that is absolutely beautiful. So, okay, brilliant. Yes, that's all look absolutely perfect. So, the only thing that you would do, yeah, so with your answer there, you would employ logical rounding. That would be the idea there that you would work with. Astra, sorry, yeah, so Astra, yeah, you would employ the logical rounding. Tina, you've done the same thing there as well. So the only thing I would say is with your answers, when you end up with how many boxes you need, think about what that implies. Okay, let's say for argument's sake, if we can fit 8.9 boxes on here, okay, that's the maximum limit. Okay, I can't round it up to 9 because if I put more weight, the tires are going to blow off, and we've just got a load of irons stuck on a truck, which is a rubbish way to end your day. So even if it was 8.1, we're going to round it down. 8.6, we're going to round it down. We have to go with the smaller value of a whole block there. But some really, really good answers. What I'm going to do, I'm just going to quickly go through and demonstrate a method of how to kind of bullet point these, how to kind of start working with them. And then we can go from there. Melissa, yours is absolutely, it's a very good idea. And it's very, very close. The only thing that's gone a little bit off there for you is the conversion right at the beginning. It shouldn't be 50, it should be 5. Okay, 100 centimeters in a meter. If you put that in, it should start to kind of change the outcomes a little bit there. But I will highlight where these marks come from now for everyone so that you're aware. And this is the main thing with these bigger questions. Even if you don't get it 100% correct, you can still get a lot of the marks. So there's a few different ways that you can look at these problems. You can look at them. Again, you might be able to read through it and spot some of the steps. Sometimes it's easier to work from the end and work backwards and think, well, at the end, I need to know, what's the total cost? Well, to know the total cost, I need to know how many blocks on the truck. Well, to know how many blocks will fit on the truck, I need to know the weight of a block. Because then I can do how many of those amounts of weights will fit safely. So to know the weight of a block, I need to have the volume times the density. To find this, I need to know, well, first of all, what's the volume? And then, as I mentioned before, with any of these questions, we want to glance straight away and think, well, what am I calculating here? We know we're finding a volume. What about the units? So all of you have done absolutely brilliantly in spotting that there is a conversion of units that needs to be done at the beginning. Now, I can't stress enough, the more of these kinds of questions you do, the more you're going to get used to these. The core skills are there. We know how to find a volume, but we need to be confident with this in different contexts. So I've jotted down the steps. What this means for me is I know that if I get a little bit lost, if I don't know how to use this formula, I'm lacking confidence a little bit, maybe I've forgotten how to find volume. I can still just find the units here. I can convert the units. That's going to get me 1 mark. I might not be able to then find the volume, but I might look and think, oh, whatever the volume is, I've just got to times it by the density. I know the density is this amount. Make it up. Just say volume equals 9. It's not going to be right, but when you multiply whatever volume you have by the density, you will get another mark. The weight of the block will therefore be there for you. You can work out how many blocks fit on the truck. Now, the total cost will not be right there either, but you're still going to then get 3 out of these marks. So that's the main idea here. By bullet pointing it down, you can spot the bits that you can answer. Very common with circle questions. People forget the circle formula. Make it up. If you know that all you have to do is have that answer and use it moving forward, they will award you for this, which is the really nice thing that they tend to do here. So our first conversion there, and what we need to do is to say, well, 500 centimeters, that is going to be 5 meters. Just again, we have to remember these things. 100 centimeters in 1 meter. We're going to convert everything into meters. The reason so, I mean, we've already got 2 measures that are in meters anyway. So, it's easier to convert 1 than it is 2. But also when we look here, we can see that our density is in meters cubed. So we want to convert everything into meters. A quick division of 100 gives us 1 mark there. Now, hopefully what we can then do is then go through and say, well, what is the volume then? So that is going to be 5 times 10 times 20. The volume is 1,000 meters cubed. Okay, so how much does it weigh then? Well, I need to know the density. I need to know how much does 1 meter cubed weigh. I know that 1 meter cubed weighs 0.5. That's its density. The density is 0.5. I've got 1,000 lots of this, so 1,000 times 0.5 gives me my mass. Again, just the weight, that's all it is. So I end up with a weight here of 500 kilograms. Okay, so each block weighs 500 kilograms. Now, the truck can safely hold 2,600. So what you can do is you can go through here and you can go, okay, well, 500, that's 1 block, 1,000, 2 blocks, 1,500, 3 blocks, and so on and so forth. Or we can do it the quicker way again, just by using those reverse calculations. We can say 2,600 divided by 500, and it will tell you exactly how many blocks you need. 5.2 blocks will fit on here. Now, they don't do 0.2 of a block. They won't do it for us. We can't round it up. Even if this was 5.9999999, we can't put any more on there. That is the absolute maximum. The wheels will blow off. It is rubbish. So all we're going to do is we're going to say, right, well, 5.2 blocks, that means the most I can have is 5 blocks. The final step, well, if each block is £21.60, I need 5 lots of it. I'm going to end up with £108 there. Okay, now, given that explanation, I know a couple of people, I can see from the workings, a few people have got very close. They just hadn't rounded this value. Now, if you haven't rounded this value, you're still going to get a mark for converting the units, for the volume, for calculating the mass there, and even for working out how much can fit on the truck. That's going to be 4 marks. The only bit you're going to drop is this kind of logical rounding step at the end. So that's going to be one that can actually cost you. So you're still going to get the majority of the marks. That's what I'm trying to get at. Now, before we move on and kind of conclude, are there any questions about this question in particular? Any questions at all regarding this? Like that, the absolute silence. So everyone going, no, absolutely nailed it. I've got no worries. I'll be fine. It is a complicated question. It is a little bit of a tough one there. And that's a really, really good question. Someone just said that, like, how do I know when to logically round something? It's just in the context of the question here. It will say that you have to, normally it will say it as well. It will say you can only buy whole packs, or you can only buy whole tins, or you can only buy entire packets, whatever it might be. They don't say it all the time, and if they don't clearly state it, you'll still get all the marks. So here, because it doesn't mention that you must use whole units, actually, so Tina and Astra, you would have both got full marks, because it doesn't clearly say that you cannot have a smaller method. Now, I have seen 1 or 2 questions where it's just been expected that you would kind of know this. So if you end up with, 5.4 packs of dog food, you kind of know, I can't have 0.4 of a pack of dog food. Yes, you are then working out the exact amount, but then if the question says how many packs do you need or how much will it cost, that's where we kind of make that link there, and we think, well, if I was paying exactly per part of a pack, it would be this much, but I have to buy the full pack there. I hope that kind of answers the question a little bit. I would just say, err on the side of safety. Just imagine, could I buy a smaller pot of paint? If it's not told me specifically what that is, just imagine walking into a shop and saying, take this tin of paint, but chop it at 0.2, please. And imagine what the response would be. But bear in mind as well that if you don't do that, you're not going to drop all the marks, and it's very likely that they're going to give you all the marks as well. Remember, we are marking to award and not to penalise, essentially. Now, as always, there are some extra practice questions at the end of this PowerPoint, so we can go through them if anyone would like me to. But I'm just going to quickly go through the topic review, and then that is going to conclude the session. So in today's session, we have looked at our metric conversions. These are incredibly important. As we can see, they were embedded in the last question. They tend to be very commonly embedded in our area questions, making them worth more marks. Okay, not more difficult, just worth more marks. But again, you might get a random question, quite common for level 1, on maybe a non-calculator paper, just saying, how many grams are in this many kilograms? How many liters are in this many milliliters, etc. So they might just ask you that. We need to be able to remember exactly what those conversions are between metric measures, okay? Imperial measures, miles, pints, gallons, all this. Forget about it. It might pop up, but it will be embedded in a ratio question. Now, we've looked at our main type of compound measure. It is speed. Speed, distance, time. You must be able to remember that triangle, okay? That is the more common of the two to pop up. But again, this is not a core topic. So it might pop up, it might not. You're better, if this is a difficult topic for you, you're better having a stronger understanding of your fractions, percentages, and ratios, because they're going to pop up. This one might not. Fingers crossed it doesn't for you. The final question then that we've had here is we've kind of spoke about the problems with the units of time as well, and decimal time, and I hope that helps. And then we've talked about our mass, density, and volume. All this is essentially is a formula question. Okay, it could be that they would apply this to anything. They might give you the measurement around the perimeter of a room, and I don't know, they could give you the formula for how to measure electrical current and then give you the numbers. All you have to do is put the numbers in and you get your answer. With these, it's very common though that you have to calculate the volume, then you use that to find the weight, you use that to then find out how much of something you need or how much it costs. Okay, very similar to those area questions where it's what's the area, how many packs do I need, how much does it cost? It's these logical steps they tend to use very frequently. Okay, so that is everything for this session. So I'm just going to stop the recording there. I'd recommend to anyone watching this in the future, I do apologize for my constant coughing. I know it's very annoying. But also on top of that, I would recommend, if you haven't got access to the Google Classroom, pop me an email and I'll get that for you. And, you know, look at the compound measures assessment as well. It's going to be really useful for you.